Have you ever tried to get an AI image generator, to write something specific?
Yeah.
Like maybe a quote with a couple of lines or a tricky product name?
Oh, yeah. And it just comes out as, well, complete gibberish, right?
Exactly. Or you try to make just a tiny little edit, like changing one word on a sign, and the whole picture around it gets completely mangled. Feels like you're speaking a different language sometimes, doesn't it?
Totally. The explosion in AI images has been wild, but getting them to understand really nuanced commands, especially, like you said, with text involved, that's been a huge headache.
Welcome to the AI Checkpoints. Today we're doing a deep dive into something pretty exciting called Qwen-Image. And look, this isn't just another model spitting out pretty pictures.
No, it's quite a bit more. It's a foundational model, part of the Qwen series, and it seems to be seriously pushing the envelope on what AI can handle visually, especially with text rendering, getting words right, and doing really precise, targeted edits.
So our mission today is basically to unpack the what, why, and how of Qwen-Image. We want to dig into the clever ways it's tackling some of these, frankly, really tough visual challenges for AI.
Yeah, and why these steps forward actually matter for, everyday use, whether you're a pro creator or just someone messing around with AI tools.
Right. And what it might signal for where AI is headed next. We've got some great material to work with, including a pretty detailed research paper that lays it all out. So let's get you properly informed. Okay, let's unpack this. We've all felt that frustration, haven't we? AI struggling with clear text, readable text inside an image. Or you try that precise edit and whoops, the background is suddenly completely different. These are real sticking points.
They really are.
So what is it about Qwen-Image? What makes it special right off the bat? What's its core promise here?
Well, what's really interesting, and the paper highlights this right away, is that Qwen-Image seems purpose-built to hit those two pain points you just mentioned, head on. It's described as a novel image generation model in the Qwen family, specifically designed to overcome these, well, critical challenges. So first, think about those complex text-to-image prompts. Even the really advanced commercial models, they often stumble with things like multi-line text, right? Or languages that aren't English, like Chinese characters, or just trying to place text accurately somewhere specific in the image, making it look like it actually belongs there.
Yeah, often looks tacked on or just wrong.
Exactly. Gibberish, weird placement. Qwen-Image is really aiming to fix that, to make text a sort of first-class citizen in the generated image.
Okay, so better text handling. What's the second main thing?
The second big focus is precise image editing, and the challenges there are twofold. Visual consistency, meaning if you edit one part, the rest of the image stays the same, it doesn't get messed up.
Right, surgical precision.
Exactly. And the other part is semantic coherence. So preserving the overall meaning, even if you make structural changes. Like if you change a person's pose, you don't want their face or clothes to suddenly change or the background to shift, right? You want the core meaning, the identity, to stay intact.
Gotcha. So fixing the text problem and nailing precise, consistent edits.
That's the core goal. And the paper points to three key contributions that Qwen-Image brings to the table. First, just superior text rendering. It's good with multi-line stuff, understands paragraph meaning, gets fine details right. And crucially, it handles both English-style alphabetic languages and logographic ones like Chinese really well. High fidelity.
Okay, that's huge, especially the multi-language part.
Definitely. Second, consistent image editing. It apparently shows really strong performance in keeping both the meaning and the visual realism intact during those tricky edits.
And the third.
And third, it just performs really well across the board. On various benchmarks for both generation and editing, it consistently outperforms existing models. Shows it's pretty robust.
Okay, this is where it gets really fascinating for me. How? How do they actually build something that can tackle these problems? Because let's be honest, rendering good text in images has stumped AI for ages. What's under the hood? What's the secret sauce here?
Yeah, it's definitely a significant engineering effort, not just a small tweak. The paper explains it's built on three main components working together really tightly.
Okay.
First, there's a multimodal large language model, or MLLM. Specifically, they use Qwen 2.5 VL. Think of this as the brain, the part that understands both the words you type and the image context.
So it gets both text and pictures.
Exactly. It acts as the condition encoder for your text commands. And because its understanding of language and visuals is already kind of pre-aligned, it's really good at interpreting complex instructions, which is key for both generation and, importantly, for enabling that nuanced editing.
All right, component one, the smart interpreter. What's next?
Next up is the variational autoencoder, the VAE. You can think of this as the image tokenizer or maybe the sculptor. It takes an image, compresses it into a compact code the AI understands, and then decodes it back into the final picture.
Okay, standard stuff for image models, right?
Well, yes, but here's a key detail from the paper. They specifically fine-tuned the decoder part of this VAE, and they trained it on a custom dataset packed with text-rich images, things like PDFs, PowerPoint slides, posters.
So they fed it examples of good text in context.
Precisely. To specifically boost its ability to render fine details and especially small text clearly. That seems to be a really critical piece for cracking the text problem.
That makes a lot of sense. And the third piece?
The third piece is the multimodal diffusion transformer, or MMDIT. This is the main engine, the backbone model, that actually generates the image pixels step by step. It learns the complex relationship between noise and the image structure, guided by the instructions from that MLLM brain.
So MLLM understands, VAE handles the image structure and detail, and MMDIT does the actual generation.
Pretty much. And they also mentioned something called MSORPE, Multimodal Scalable Rope E. It's a novel way they encode positional information for both text and image patches. Think of it like giving the AI a super precise internal grid system.
Okay, and that helps with?
It helps with better scaling to different image resolutions and really nailing the alignment between the text instructions and where things appear in the image, getting that text crisp and in the right spot.
Wow, okay, so it's this tight integration of these three parts, plus specific tweaks like that VAE fine-tuning.
Positional encoding, yeah.
But, having a great architecture is one thing. The fuel for this engine, the data it learned from, that must have been absolutely critical too, right?
Yeah.
You can't teach it good text if it never sees good text.
Absolutely critical. And the paper spends a good chunk of time, section 3, talking about their data engineering. It wasn't just about grabbing billions of images, though they did collect billions of image text pairs. It was heavily focused on the quality and the balance of that data.
Quality over just raw quantity.
Exactly. They categorized the data really carefully. About 55% was nature, objects, landscapes, animals, food, typical image stuff. But a big chunk, 27%, was categorized as design.
Design, like graphic design.
Yeah, things like posters, UIs, art, presentation slides, stuff that's naturally rich in text and often has complex layouts. They also had people and synthetic data categories.
And they cleaned it up
Rigorously. They used a whole battery of filters checking for clarity, brightness, saturation, entropy, texture, basically making sure only sharp, clear, realistic images made the cut. No blurry or noisy stuff.
Okay, but what about the text specifically? How did they ensure the data helped with that problem?
This is where it gets really clever. They developed specific strategies just for text rendering. They categorized data based on whether it had text and what language, English, Chinese, other, or no text at all. This helped balance the training.
Makes sense.
And crucially, they didn't just rely on found text. They generated synthetic text data too.
Like fake text.
Sort of. Think about generating text for characters that don't appear often, or mixing languages within one image. They generate text on simple backgrounds, or within structured templates like PowerPoint slides. This directly addresses the AI's weakness with uncommon characters or layouts.
That's smart. Fill in the gaps in real-world data.
Exactly. And they used powerful AI captioners like their own Qwen 2.5 VL again, to create really detailed descriptions and structured metadata for the images, including verbatim transcription of any text present in the image, like literally writing down exactly what the text said.
Wow, that's meticulous. So the AI learned not just that text was there, but what the text actually said.
Precisely. That level of detail in the data curation seems key.
Okay, so amazing data. How did they actually train the model with all this? Was it just one massive training run, or?
No, definitely not one shot. It was a very deliberate multi-stage process designed for huge scale. The paper talks about multi-stage pre-training, meaning they started training at lower resolutions, like 256 by 256 pixels, and progressively increased the resolution up to 1328 by 1328. At each stage, they likely refined the data quality and tuned the model. This lets the model learn coarse features first, then finer details.
Building up complexity gradually.
Right, and to handle the sheer scale, we're talking massive GPU clusters, they use what they call a producer-consumer framework.
Sounds industrial.
Kind of is. Think of it like an assembly line. You have producer processes that are just focused on preparing and loading the data efficiently. Then you have consumer processes, the GPUs doing the actual model training. They're kept separate, but tightly coordinated.
Why do that?
It maximizes efficiency. The GPUs doing the heavy lifting for training aren't waiting around for data. The producers keep them constantly fed. It helps keep the training stable and fast, especially at that scale. They mention using tools like Ray and Megatron for this.
Okay, so multi-stage pre-training efficient pipeline. What happens after that initial training? Is it done?
Not quite. There's a crucial post-training phase. First, supervised fine-tuning, or SFT. Here, they use a smaller set of very high-quality, often human-annotated data to really polish the model's output, pushing it towards greater realism and detail.
Fine-tuning with the best examples.
Exactly. And then they also use reinforcement learning, specifically mentioning techniques like direct preference optimization, or DPO. This is where the model learns from feedback, basically, learning what humans consider a better image compared to another and adjusting its output accordingly.
So it learns our preferences for quality.
Yeah, optimizing for what looks best to us. And finally, one more key thing is the multitask training strategy. Because they use that powerful Qwen 2.5 VLMLLM and the VAE embeddings, the model isn't just a text-to-image generator.
It can do more.
Yeah, it can natively handle image inputs too. So it can do instruction-based image editing, like we talked about. It can do novel view synthesis, creating images of an object from different angles. And it can even tackle some traditional computer vision tasks, like estimating depth in a scene. It's quite versatile.
Wow, okay. So that's a lot of sophisticated engineering and training methodology. Which brings us back to the main question. Does it actually work? What does this all mean for us, the users? What's the real-world performance like?
Right. The proof is in the pudding, isn't it? And based on the paper's results, the answer seems to be a pretty strong yes. The performance evaluations are quite compelling.
Like what? What stands out?
Well, one big thing they highlight is performance on the AI Arena benchmark. This is an open platform where models compete head-to-head, rated using an ELO system, like in chess.
Okay.
They tested Qwen-Image against top commercial models, Imagen 4 Ultra Preview, Seedream 3.0, GPT-Image 1, and Qwen-Image, which remember is the only open source model in that specific comparison they showed.
Yeah, how did it do?
It ranked third overall. Now, it was still behind Imagen 4 by about 30 ELO points, which is understandable given Imagen's resources, but it significantly outperformed GPT-Image 1 and another model called FLU X.1 Context by over 30 ELO points.
Wow. So an open source model holding its own, even beating some major closed source players, that is a big deal.
It really is. It shows the approach is genuinely competitive at the highest level.
And what about the text rendering specifically? That was a key promise. The benchmarks back that up.
Oh, yeah, absolutely. They tested it on several text-focused benchmarks. On one called 1IG Bench, covering both English and Chinese, it ranked first in alignment and text categories.
First place.
Nice. They also used a new benchmark specifically for Chinese characters called Chinese Word, and Qwen-Image got the highest accuracy across all difficulty levels there, too.
Impressive. Especially the Chinese text. That seems particularly hard.
It is. And on another one, Long Text Bench, it got the highest score for long Chinese text and was second highest for long English text. The qualitative examples they show are really convincing, too.
Like what kind of examples?
They show it avoiding common errors like missing words, wrong words, duplicate characters. There are examples of it rendering long English paragraphs accurately, handling multiple distinct text boxes within one image, and even nailing a complex Chinese couplet, getting both the content and the artistic style right.
That's the kind of detail that makes a real difference.
It even rendered structured paragraphs onto tricky surfaces like glass panels in one example. Really impressive control.
Okay, text rendering sounds like a clear win. What about the editing side? You said it was a major focus too.
Equally strong results there. On editing benchmarks like Jedit Bench and an edit covering both English and Chinese instructions, it ranked right at the top, demonstrating really competitive instruction following for edits.
Can you give some examples of the kinds of edits it can handle well?
Sure. The paper shows things like text and material editing, for instance, changing the word hope on some artwork to Qwen while perfectly keeping the original artistic style, or taking a prompt like make it look like enamel-colored glass art and applying that texture realistically.
Wow, changing materials like that.
Yeah. And object manipulation, adding a cartoon cat and dog into a scene, matching the style, or cleanly removing people from a photo, filling in the background plausibly.
Okay, that's useful. What about more structural changes, like poses?
That's where it gets really remarkable. They show examples of changing a person's pose while preserving tiny details like individual hair strands. The background stays consistent, the clothing stays consistent. It can even, get this, infer details like if you change a pose, it might reveal that the person was wearing side-slit trousers under a dress, details that weren't visible before but are consistent with the outfit.
That implies a much deeper understanding of the scene, doesn't it? Not just pixel pushing.
Exactly. It suggests a real grasp of 3D structure and object properties.
And can it string edits together, like do step one, then step two?
Yes, they call it chained editing. They show an example of extracting a rib from an image and then generating a close-up view specifically of the rib's fabric details, maintaining the texture fidelity across both steps.
Very cool. And you mentioned novel view synthesis earlier.
Right. It apparently achieves state-of-the-art results there too, generating consistent new viewpoints of complex real-world scenes, even when rotated significantly, which again points towards potential future use in video or 3D.
Okay, so the performance seems genuinely impressive both on text and editing. Let's zoom out then. What are the bigger implications here? Beyond just being a better image tool, what does Qwen-Image signal for AI's future?
Well, the paper suggests a few key takeaways in its final section. First, it represents a shift in focus for generative AI. It's moving beyond just chasing photorealism or a generic AI aesthetic,
Towards what?
towards prioritizing precise control and alignment, especially between text and image. It's about accuracy and user intent, not just making something that looks plausible. Think about use cases where the text has to be like labels, instructions, diagrams, ads with legal text. This level of control opens those doors.
Right, where precision matters more than just prettiness.
Exactly. Second, it paves the way for what they term vision language user interfaces, VLUIs.
VLUIs.
Yeah, imagine describing a complex idea, maybe a scientific concept or a business process, and the AI doesn't just give you text back. It generates a rich illustration with integrated, accurate text that visually explains your abstract concept.
So, interacting with AI more visually, using images and text together seamlessly.
Precisely. It's a move from just typing commands to a richer visual dialogue with the AI. True visual language understanding.
Interesting. What else?
Another point is about generative understanding. It shows that these powerful generative models can actually perform tasks we normally think of as requiring understanding, like depth estimation or inferring object properties, not through specialized analysis, but as a byproduct of learning to generate realistic and consistent scenes.
So, creating becomes a form of understanding.
Kind of, yeah. It suggests generation and understanding might be more deeply linked in AI than we previously thought. It changes how we think about AI getting it.
And you mentioned video and 3D potential.
Right. The architecture choices, like using a VAE potentially suitable for video, combined with its strong performance in pose editing and generating new views, strongly suggest this could be a foundational step towards much better AI video and 3D generation down the line. It's building the right kind of understanding for dynamic scenes.
So it's laying groundwork.
Seems like it. And finally, they see Qwen-Image as filling a key generation gap, complementing models like their own Qwen 2.5 VL, which excels at the understanding part. The ultimate goal seems to be a unified system, a visual language omni-system, where AI can perceive the world and create within it seamlessly, truly interactive, intelligent agents.
This deep dive into Qwen-Image, it really does feel like a glimpse into that next phase, where AI isn't just about making bigger models, but smarter ones, more controllable ones, models that actually nail the details that frustrate us users the most. It's genuinely exciting to see that line between understanding and generation getting blurrier.
Absolutely. That ability to really control the text, keep things consistent during complex edits, even infer things like depth or generate new views just from the generative process. Yeah, it opens up a massive new playground for creatives, for developers, even just for casual users trying to bring a specific idea to life with a level of accuracy we just haven't had before.
So the big question for everyone listening is, what will you create? When you have an AI that doesn't just guess, but actually seems to understand every little nuance of your vision from the whole scene right down to the smallest perfectly spelled word.
Hit like and subscribe if you like the content. See you next time.